So guys, in our previous video, we have actually seen the convergence algorithm of the simple linear regression. In this video, we are going to talk about multiple linear regression, and we're going to just understand what is the basic difference between simple linear regression and multiple linear regression. In our previous example, when I consider our data set, right, we have taken the example that my input feature is probably, weight. So I really need to predict height. Okay. And for this, this is specifically one input feature over here, one input or independent feature, and this is specifically my output feature. So what we did with the help of simple linear regression is that we tried to find out the best fit line, and we understood the equation, the cost functions, the convergence algorithm of updating the slope. Now in this particular case, since I just have one input feature, so if I talk about the h theta of x, which is the equation of the straight line, which we have actually discussed, we are indicating something like theta 0 plus theta 1 multiplied by x, right? Now over here, this x basically indicates my input feature, right? Input or independent feature, right? And obviously, you know what is theta 0? Theta 0 is basically intercept, and theta 1 is nothing but slope, right? Now, what we were doing is over here is that we were trying to change theta 0 and theta 1. We will not change x. X, whatever is there in this training data set, that only things we are going to take and probably train our model, right? So in this particular case, what we will do, we'll just change theta 0 and theta 1 and we'll try to find out the best fit line. Now, what if in your data set, you have multiple input feature? So let's consider one simple data set. I call this particular data set, which is called as house pricing data set. Okay, now in this house pricing data set, and probably I'll show you this all kind of data set when we do the practical, right? Let's say I have multiple features like this: number of rooms in the house, size of the house, okay, and let's say what is the location of the house, and finally I have something called as price of the house. So over here in this particular problem statement, here you can see that I have four features over here, 4 features in total, and this first 3 features are basically my input features, right? This first 3 features are basically my input features or independent features. So I'm just going to write this as independent features. Now in this particular case, you can see that I have more than one input feature or independent feature, and this is my output feature. Now in this particular case, when we try to find out a best fit line, how does the equation of the best fit line look like? So now I'm going to basically use the same equation, h theta of x, which is nothing but theta 0. Theta 0 is always an intercept. There will always be one intercept for any kind of regression problem, or if I'm basically using simple linear regression or multiple linear regression, there'll always be one intercept that we really need to use it. Along with this, based on the number of features, right? Let's consider number of rooms is my x1 feature. So for this, we will be having another slope, which I'm mentioning over here as theta 1. Then I will be having for my second feature, theta 2. So theta 2 is the slope for size of house or coefficient of the size of house. Okay. And similarly, location will be theta 3, x3. x3 basically indicates location, right? And theta 3 is basically the coefficient. So this equation basically indicates my multiple linear regression. Okay. So in the case of multiple linear regression, one important thing that you really need to understand is that we will definitely have many features. Okay. Here in this particular case, I've taken 3 features. So with respect to these 3 features, I will be having 3 coefficients. So over here, theta 1, theta 2, and theta 3 are basically my 3 slopes or coefficients. Okay. So as the number of input features increases, that many number of coefficient will increase, but your theta 0 will always be the intercept, and you will have only one intercept all the time. Now in this particular case, if I probably talk about our gradient descent, let's say since there are 3 input features, in this particular case, when I draw with respect to theta 0, not theta 0. So let's say theta 0 is here, then I have theta 1 over here, and probably we cannot draw 4D diagram. So let's consider just 2 features. Here I'm just considering theta 0 and theta 1. Okay. And with respect to this, suppose I have j of theta over here, right? So we usually get a different types of diagram, which will be looking like a inverted mountain. Okay, so let's say that this is my gradient descent curve. Okay, and here you will be seeing something like this, right? And our aim is to basically come over here. So theta 0 can start from this point, theta 1 can start from this point, and let's say if you are using theta 2 or theta 3, it can probably start from this point. But everybody's aim is basically to merge or converge to this global minima. Okay, so this is how we basically solve multiple linear regression. Obviously I cannot show you some kind of simulation and all. Let me see if I get any simulation tool in this particular course to put up, but just understand that in this particular case we have many coefficients and we have to keep on changing theta 0, theta 1, theta 2, theta 3, and try to reduce our cost function j of theta. Now over here I can basically write j of theta as something like this. So I can have j of theta 0, theta 1. Now in this particular case, since I have taken theta 0 and theta 1, so I'm just going to mention it like this. Okay, so this is what multiple linear regression is all about. In multiple linear regression, we are focusing on, right, like our input features will be more, not just only one. If we just have one input feature, we basically say it as simple linear regression. If we have more than one input feature, we basically say multiple linear regression. Okay, so this was the basic difference. I hope you have understood this. In the upcoming videos, we are also going to understand some amazing assumptions about linear regression, and these assumptions are very important to understand. So let's go ahead towards the next video. Thank you.